Wanted to go ahead and create a little screencast tutorial on processing your data from Experiment D. I think in the past we've had a few things. I think it's been oriented differently, things like that. But I've decided to go ahead and also go ahead and interpret a little bit more of what you're supposed to be, what you should be thinking about and being concerned about while processing this data. Well, if you remember the C and D values, you put all the Bradford data in. So let's go ahead and put Bradford here. I like labeling the spreadsheet so I know what it is. And VCA I'll put in here. The first 9 values here are going to be Bradford data, so that's going to make that light blue. And the BCA data, I don't think we have kind of a light purple, but let's go ahead and make it yellow. Then here is the unknown data. We have some unknowns to deal with. Let's make them bright yellow so they stand out. We'll deal with those sort of second. We'll deal with the standard curves first. So deal with the standard curve. What we did is we took duplicates of each one to help minimize some of the error. And taking means kind of helps mitigate some of that. So we took means. So we're going to head and type in average in Excel. And take the average of these first 2 values. Hit that in there. What we also did was our standard, we started off with 2 meg per mil, 1 meg, 0.5, 0.25, 0.125, and so on. So let's go ahead and generate that part here as well. Equal to this divided by 2. So it's this divided by 2 equals, and we'll take that all the way down, down to here, to about here, I think. That's probably as far as it goes. We'll take this down that same value there. And while I'm doing 2 and I'm doing a comparison, I want to make sure that I process all the data the same way. So what I'm going to do is the same thing. It's equal to that, enter, is equal to this divided by 2, hit enter, and then drag that over to here. And that is equal to the average of these 2 values. And we drag, and you remember to copy values and equations and all that, you just take the cell and just kind of scroll it over and you copy it. So we have this now. Now we don't need to be looking at this so much anymore. We'll just go ahead and scroll a little bit further over. Need a little bit of room here, so let's go ahead and just hit the little scroll over button a little bit. And let's go ahead and what I always do is when I told you whenever you do a standard curve, one of the first things you should do after, you should plot every one of them and look at them to make sure the range is completely linear and that sort of thing. So we're going to head and we're going to just graph that data. So it's insert, charts, and I like to do without any lines because I'm going to be adding my own line. And this is going to be, this is the Bradford data, so this is Bradford data. And, later on we can go ahead and, we can add elements to the chart, axes titles, primary horizontal. We go ahead and put milligrams per ml. And add elements, axis, primary vertical, and that's absorbance. Okay, so we have a standard curve here. It's starting to look, it looks pretty good. Let's go ahead and add a trend line. and look at the equation on the chart and put the r squared on the chart. And we do that, and our r squared is 0.956, which is could be okay, but I'm looking at this data and it looks like the 2 mg per mil looks like it really should be up in here, not down in here. So I'll keep that in mind, but let's go ahead and look at the BCA data. Let's go ahead and do that graph. And insert charts here. Move that down here like this. Move that chart down here. What I'll do is go ahead and title that BCA data. And the reason one of the reasons I'm doing this is I'm going to be generating a lot of these things on here, so I want to label them as I go. And chart elements, horizontal axis, it's milligrams per ml. With that plus sign. Okay, formulas, page formula. Oh, we need to get back into the graph mode. Okay, let's go ahead and do this. So we go ahead and put the line in, format data series. Oops, that's the wrong one. Format, add trend line. Sorry, I meant to do that. And display the equation on the chart and display r squared on the chart. Oh, look at this equation. Look at this r squared is 0.9961. This BCA data looks really, really good, and I would think that this curve is going to be very valid for any calculations, anything that you want to make. But on the other hand, this Bradford data one, this point looks like it's off. So let's go ahead and generate another graph, eliminating that highest data point. So we highlight everything else, go insert charts here, put that here, and we go ahead and add a trend line here. And that trend line is 0.9941, and that's actually a much better one. And we can see that all the points are very close to the line. While this one, it looks like, and I'm looking here, I was looking here, and what I did was I noticed that these points here all look like they're very much in a line, while this one definitely looked different. So I think that the Bradford data is not really is not good to 2 mg per mil, but it's definitely looks, in this case, it looks like it's good to 1 mg per mil. So I'm going to do the calculations here. So on your graph, I'll call this whoops. So this is the redrawn Bradford curve. I misspelled Bradford. So this is the one that I'll do my calculations with. So we'll keep that in mind, that we don't want to put the 1 mg per mil in there. But if you want to, you can make some calculations. Just see how easy it is to make calculations. So these two standard curves look very good at this point. And at this point, add element, axis titles, primary horizontal as milligrams per ml. Put that up there. The conditional cell type page draw. Oh, come on, where's the graph thing? Where's the graphing line? Okay. Oh, we just need to click on this and it should go to that format. No, let's go ahead and do with that later, and I'll talk a little more about that later. We have the axis is milligrams per mil, and the other axis should be absorbance. We have these two curves. And next thing to do is we need to determine our unknown concentrations. And remember, this equation is in the form of y equals mx plus b, which m is the slope and b is the y-intercept. So we need to keep that in mind. But if we want to solve for x, we have to rearrange the equation. Let me scroll a little bit further over here and I'll write it out. So it's y is equal to, whoops, mx plus b. Well, if we want to solve for x, let's go ahead. The first step I would do along the way is y minus b is equal to mx. And then if we want to solve for x, x is equal to the quantity y minus b divided by m. So that's the equation we're going to use for determining concentration. Oh, we have the minus sign, hit the minus sign there instead of the plus. But here it is. So that's the equation we have to remember. Let's go ahead and put that calculation in. And let's go ahead and put unknown A and unknown B. We'll go ahead and take averages of them. Take the average of, these two, these two, hit enter. And if you want to go ahead and just copy that over to the next cell over, so there's that average. And we have here, go ahead and type equals average. And it's these two values, hit enter. We'll drag this over to here. So we have that. So we have the means of those. You can, if you want, to calculate, since you have the equations here, you could actually copy the slope and the y-intercept from the actual equations I had you print here. But what I like to do is to go ahead and calculate them because Excel will calculate them for you. So the slope is equal to these values. Remember, we're going to go to 1 here. You do comma, and you highlight all of these and hit enter. So that slope here is the same as here. See that 1.11, 1.11, it's the same. And then we'll type slope here and intercept here. And the intercept is a very similar equation. It's intercept. And you highlight the same values, comma, and this one, hit enter. This 0.231, 0.232, that would round, so those numbers are valid. And what I do is I like to go ahead and make sure that the values are very equivalent. And that's sort of one of my proofreading steps because, I do make typing mistakes. Copy, paste, and put slope is equal to slope. And here, remember, we have all of the values. .108, that's good, is equal to intercept, which is equal to this, comma, this, hit enter, and the intercept 2.237, that would be 37, those values are good. Now, as we have absorbance for these unknowns, you want to determine the concentration. So the concentration is equal to that value here minus the intercept, close that, divide by the slope, hit enter. So there we have the concentration of that sample. And since we're going to be copying things, if you put a $sign by a value, that means that it won't move. If you copy it, it'll be the same value. And we'll copy it over to here. And we have those two concentrations. So it says that we determined that to be about 0.46, maybe 0.47. This is 1.45. Let's go ahead and do the concentrations here. Is equal to their y, which is this value, minus b, which is that value. Close that here and divide by the slope. And we have the value here. We go ahead and put the dollar signs in to make sure we can copy without things moving around. Now this equation and this thing is something you're going to have to do multiple times this semester. And you have the value here. So we have here the concentrations, and we have all the values. So in your report, I want you to include the BCA data curve, the Bradford data curve that you changed, and we changed, and have put this curve in. And I want you to generate a table that looks something like this. Let's go ahead and enter the table in here. Is that Bradford, BCA, unknown A, unknown B. So once you generate a table with those values, and I'll just go ahead and do those here, is equal to this. Enter, copy over like that. And here it's equal to this value, enter, drag it over. Now, one of the things is, I see this looks like there's 6 significant figures here. I mean, there's 7 here. And these methods are not like 0.00001% accurate. So what I do here is I take advantage of Excel kind of doing things for me. Whoops. And I report the 2 significant figures. And here, and so these are the values that I put in the table. So the values you're going to need for your report are a table with these values. And this would be figure 1. This would be figure 2. And this would be figure 3. And I want you to go ahead and analyze all that data, answer all the questions that I have for you, and that's what you need to do for experiment D. Hope this makes a lot of sense to you. I played around and moved around a lot in Excel here, but then wind up copying all this data into PowerPoint. I mean, into Word. So I'll do that, just copy, and you can paste that in. So I will see you later, and good luck. If you have any questions, send me an email or drop by my office hours. See ya. Bye.